Hello, and yes, welcome to AMS Weather Band's latest webinar, AMS Weather Band Breaking News Event, Historic Hurricane Hilary, with Kim Wood and moderated by Doug Hildebrand. Before we begin, I would like to address some of the guidelines for our webinar today. If you have any questions during this event, please make sure to put them in the Q&A at the bottom of your screen. Questions for speakers submitted through the chat will not be considered. And we will also have some specific time for questions from the audience after the presentation. Now I'd like to introduce today's moderator. Doug, thank you so much for joining us. Folks, Doug Hildebrand, with 20 years in the National Weather Service, leads programs promoting weather readiness and resilience. As chair of the AMS Weather Band Committee and through various roles, he's driven collaboration, drafted AMS statements, and worked to reduce lightning-related deaths. And with that being said, Doug, the floor is yours. Thank you.
Thank you, Gideon. I want to thank everybody for taking time out in their day. If they're on the West Coast or farther to the west, good morning. For those on the East Coast, good afternoon. And even those who may see this at a later time, good evening. But we have a really historic event, as the title tells everybody, Hilary. And we have a fabulous speaker who actually, for those who may be remembering last year, Dr. Kim Wood spoke on Hurricane Ian as it was approaching the western coast of Florida. And boy, what an impact that had. And so Dr. Kim Wood is associate professor, a newly associate professor at the University of Arizona at the Department of Hydrology and Atmospheric Sciences. That looks like to be a good department in following Hurricane Hilary. And so let's just get down to it. What are the takeaways, Kim?
Thank you so much for being here. Thank you so much for having me and for that lovely introduction. I've got a few things that I'm going to share to give some context for what is making this storm historic and why it's having some of the impacts that we've observed. This map is depicting in red the working best track. We say working best track because it is the real-time operational estimate of where the storm was every 6 hours. After the season's over, the National Hurricane Center will review all the data to make sure that this is as accurate as possible. All of the black lines you see here are what they've done for the record. Since 1949, we have tracks of storms here in the eastern North Pacific, and this red line helps show just how unusual Hilary's track was. These lines are restricted to when the storm had a tropical or subtropical designation. So if it wasn't yet tropical or became post-tropical, that's not drawn on here. So that helps highlight just how unusual it is to get a storm north of the US-Mexico border that is still tropical in nature. If we look at some of those storms and zoom in a bit, I drew these lines in blue because it does include some of that post-tropical or extratropical designation. So we see here that there have been some, if we zoom in, that have crossed or gotten very close to crossing the Mexico-California border. And I wanted to pick on a couple of them, just to give some context for the behavior of Hilary based on what we've seen here in the past. So I'm going to bring up GenCath, which is short for Jennifer Catherine, because at the time they thought it was two different storms. Turns out when they went back and looked at the data, it was the same storm that just happened to have two names. Kathleen, which happened in 1976, and then Nora, which is probably the closest as far as still being tropical, truly tropical, into California, which occurred in 1997, which was also an El Nino year. This is an animation from the ERA5 reanalysis. So these aren't strictly observations, they're observations plus a forecast model to try to give us a better guess of the state of the atmosphere rather than at points across a whole domain like what we see here. The shading that you see here with the graph or the color bar on the right, that is relative humidity. And the lines are 500 hectopascal or millibar geopotential height. So it's a sense of how far up do you get, or how high up are you in the atmosphere when you hit 500 hectopascals? The higher up you are, that's higher pressure. The lower you are, that's lower pressure. So when the numbers get smaller, that implies that that surface is closer to the ground and that the pressure is lower. So that often indicates a low pressure system. So here in this example from 1963, we see this lower pressure system coming in. Kind of looks familiar, doesn't it? If you were watching Hilary, coming in to greet the tropical cyclone that is coming in from the south. A lot of dry air here, but a huge surge of moisture coming in associated with that northward moving system. We move ahead to Kathleen. It's not exactly the same setup. You do have the drier air off to the west, the more moist air off to the east associated with the storm, but the low pressure system's in a little different configuration, kind of a cutoff low that's a bit farther south compared to what we observed for that previous case. And finally, we'll look at Nora. Pretty dry off to the west here, but again, we've got that lower pressure helping to steer the storm north, and that blob of moisture associated with the storm itself being brought into the northwest Mexico and the southwest US as it kind of gets squeezed between these systems. So we've got that lower pressure over here, and then the other region I didn't really talk about to the east of these cases is a high pressure system that we often refer to as a ridge. So none of these behaved exactly the same, but we did see some similarities. Lower pressure off to the west, higher pressure off to the east, and our storm of interest kind of getting squeezed between them. Now, there have been some questions about how did Hilary itself end up coming to be what it was? And a contributor, not the contributor, but one of the contributors is going to be the sea surface temperature, or SST. This is a map from NOAA of the weekly average SST. I've got the link down here if you're curious about investigating yourself. And this color bar down here corresponds with what we see. So we've got quite warm water here off the coast of Mexico, close to where Hilary developed. That's over 30 degrees Celsius. That's, bath water. Unfortunately, also bath water out in the Gulf of Mexico right now. But as we gain latitude, so going farther north, pretty quick change in temperature. We see a lot of different shading here because the SSTs are decreasing rather quickly over a given distance. Now, one of the things that we look at for sea surface temperature isn't just what are the raw values, but how do they compare to normal? And that's when we bring in the anomalies. And here we see that water's pretty close to Mexico, a bit warmer than usual, but not necessarily the case across the entire region. So we do have some warmer than normal water, but in the context of what a tropical cyclone tends to like, which is water above 26 degrees Celsius, they're still pretty cold by a tropical cyclone standards as we get to the northern coast of Baja California and toward the coast of the state of California. Now, one of the things that is important to consider isn't just what are the SSTs now, but have they been changing over time? And yes, they've been warming up. This color scale has the capability of showing negative values, meaning that they are cooling over time, but nowhere in the domain is that actually happening in this particular example. So if we look at the change per decade, we're seeing, 0.15, 0.2 degrees Celsius, which doesn't sound like a lot, but, over the course of over 6 decades, that adds up to more than a degree Celsius of warming. So we do see that the area where Hilary traversed has been warming, and a pretty sizable amount of warming, relatively speaking, for the month of August, which is when Hilary happened, for this region that's right off of the coast of Baja California. So even though we do have that sharp SST gradient, that quick change in SST over distance, overall that whole area is getting warmer over time. So one of the things to think about as well is, why did this happen? Usually storms don't do this, right? We saw that with the track map, that it's pretty unusual to get those northward tracks. Well, that's because there's usually something in the way. And that something is the high pressure system that I briefly referenced when looking at those animations earlier. Usually we've got a ridge or a high pressure system parked over the southwest US. The flow around that, which you can hopefully see by these arrows here, is clockwise. And so most of the time, the flow to the south of this clockwise spin is from east to west. And so that means storms usually move from east to west in the eastern North Pacific. But occasionally, they can get caught by an incoming low pressure system that changes the overall flow in the region, which results in the ability of a storm to gain latitude, to move northward. So yes, usually we've got something like what you see on these maps in place to cause storms to just kind of truck westward. But sometimes something will come in to disrupt that normal flow. And if a storm happens to be present when that disruption occurs, it can turn northward, like what we saw with Hilary. So let's actually look at the storm. This is an animation following the storm. The circle depicts about 375 miles from the storm center. So we're following along with the storm and looking at a pretty consistent region. So we can kind of see when it becomes bigger or smaller, when it becomes more or less lopsided, like here, it gets quite lopsided as much of the clouds get shifted to its eastern side. And then we see how quickly it starts speeding up, moving northward as it gets caught by that incoming low pressure system, which we haven't actually looked at yet, but I'll show you in a moment. I'll just let it replay again to kind of see how quickly the storm organizes, how quickly it intensifies, how that large eye becomes apparent. It gets pretty nicely circular, something we call axisymmetric, near peak intensity. And then as it encounters increasing vertical wind shear, which is a change in winds with height, as it encounters some dry air, and as it runs into those lower SSTs, those colder waters, there's less energy to power the storms that we're seeing here, those clouds surrounding the eye. And so the storm starts to decrease in intensity. But as we saw with its impacts, decreasing intensity does not mean that the impacts themselves are going to be less bad. Zooming out, this is a different satellite imagery product, and we're going to look at the whole area in a fixed domain instead of trying to follow along with the storm. So we've got Hilary here, and what we're looking at right now is water vapor imagery. So you can kind of get a sense of the flow of the atmosphere, even when clouds aren't present, which can be really useful for tracking things like this low pressure system up to the north. And so we've got water vapor acting as a tracer, where you can kind of see the sloshing motion of the atmosphere over time, and how the storm down here, it's initially moving more westward, and then it starts to turn more to the north as this low pressure system comes in and gives it some of that northward boost. And then we see well ahead of the storm, the flow is just shoving moisture northward. And so there was some opportunity, unfortunately, for rain to fall ahead of Hilary and make it even worse when the rain associated with the storm itself came through Southern California, contributing to some of the flooding that was observed. This is now looking at radar. So we are capturing how what gets bounced back from the signal sent out by a radar sensor, and estimating how much rain is falling based on the signal that comes back. When you're looking at radar imagery, higher values tend to imply more rain, specifically more rain coming down at a given time. So the longer you get high reflectivity values, the more rain will fall in a spot, and thus more or add up and worsen flooding impacts. But in this 24-hour loop, which let's see, it goes from 13 UTC yesterday to 13 UTC today, which is, I think, 6 a.m. Pacific time. So it's going from 6 a.m. to 6 a.m. And we see that from that moisture streaming ahead of the storm, there was quite a bit of rainfall. And then that rain kept going and going as the storm itself came ashore. So it isn't just how heavy is it raining, but also how long lasting is that heavy rain. And when you get both heavy rain that lasts a while, that tends to exacerbate flooding impacts, especially in a place like the Southwest US, where sure, they get some heavy rain sometimes from thunderstorms, but they don't tend to last that long. And so the terrain and the way the soil is, and of course the infrastructure that we build for these climates is not geared to withstand rain of this kind of extreme. And so that's part of why you'll see a lot of flooding from, say, 6 inches of rain out here, even if somewhere else in the US, 6 inches of rain doesn't cause as many impacts. It has to do with a whole lot of factors, which includes how we build for that type of event. One of the things that got given to me shortly before this webinar was this neat comparison of the forecast amount of rainfall as well as distribution across the forecast region from San Diego, and then the actual values. So we see a lot of these higher values, as indicated on this forecast graphic, were realized. Many of those locations ended up experiencing that much rain. So even though this was a really unusual event and very difficult to describe what might happen because very few people would have experienced anything like it, our guidance that we used, both our understanding of how the atmosphere works and the forecast tools that we have at our disposal, helped highlight where that worst rainfall would occur and thus forecast it accordingly. So as we feared, a lot of rain fell, but it was forecast pretty well. And so I did want to point that out, given that there's quite a few horrendous types of images coming out of the affected areas due to rapidly rising floodwaters. Speaking of which, this shows the accumulated precipitation. So that radar animation I showed earlier was highlighting how much rain was falling every 2 minutes. It's, where was the heavy rain falling? This is adding it up over a period of time. The scale over here on the right is in inches. And so once you hit the white colors, that means at least 6 inches. It is a 48-hour graphic, but most of this rain fell in a much shorter period of time associated with the impacts from Hilary. And so quite a bit of rainfall, especially for this region, especially for this time of year, many, many records getting broken. But one of the things that it does help highlight is how terrain can impact where some of those worst rainfall amounts can be. So in a place like the Gulf Coast, if you're looking at Florida, parts of the Atlantic US coast, terrain is less of an influence on the type of rain that we get from these tropical systems. Whereas in this part of the country, that terrain is going to have an outsized impact on how much rain falls and where that heavier rain is occurring. Something else that was shown earlier today is the effects of Hilary's rainfall on soil conditions. So some of these places in California were incredibly low for how much moisture was in the dirt, in the soil. And well, and wow, in Arizona too, but now that Hilary's come through, it's getting way, way, way above normal. So the blues are indicating some very, very high values, and the reds are indicating some very low values. Some big changes in how much water is present across this region, which is great news from a, do we have water? Are we going to be experiencing bad drought conditions perspective? The problem is it happened all at once. We love getting this kind of rain or this much rain over a long period of time. It can be catastrophic when it happens in a very short period of time. And so I'm just going to come back to this animation here and allow it to loop if I can. And then I would love to take some questions.
Kim, wonderful. and I've got so many questions, but I don't want to monopolize your time. So for those who do have a question, use the Q&A feature available to you. But I'll kickstart things, Kim. Excuse me. and let's stay on this idea that, you know, whether it's the Southwest or even, you know, along the Gulf or East Coast in areas that are, you know, atypically dry, tropical systems can usually be some sort of drought buster, and there's good news associated with these storms. Do you have any early indications? You showed the graphic of the soil moisture, but the actual water capture, and are there reservoirs that may have missed this past winter with all of the series of atmospheric rivers that may, you know, be more filled to the max now with Hilary?
That's a great question. I haven't looked a lot into the what the rivers are currently doing and thus reservoirs, but I did poke around a little bit on water.weather.gov. It has a great resource for looking at the current levels of river flow. And there were some very alarming upward trends as the rainfall was at its worst over portions of California and Arizona and southern Nevada. But one of the things that was encouraging from a longer term perspective is that they didn't stay high or they didn't keep rising. They rose, they peaked, and they started coming down. So that does imply, at least in the couple of places I looked at, that we're not exceeding some capacity as far as how much water could be stored there. That said, there's a lot more data to look at to really be able to answer that, including actual reservoir gauges, which I did not poke around at, but that's an important thing to consider. It's not just how much rain fell and what did it do right now, but longer term, is that water that's going to be able to stick around and be used later for when we aren't getting rain in this area? Or was it just such a deluge that they had to just let it go and weren't able to capture as much as they might have liked?
So we have 2 questions coming in from Katie. Thank you for those. And they're sort of, well, one that I've had. And you showed the SSTs, and you showed or indicated that in 1997, we had a similar situation, and it was also an El Nino year. Would you be comfortable being affirmative of it, like, yes, because we're in an El Nino, this has occurred, or are some of the synoptic conditions conducive to Hilary existing, maybe even if there wasn't an El Nino strengthening and building up?
Yeah, the El Nino portion is complicated for a couple of reasons. Specifically with El Nino in the eastern North Pacific, that's going to increase the sea surface temperatures. And so that implies that there's more energy available to the storm when it's at lower latitudes to be able to develop its convection to then further organize and intensify. And then the presence of El Nino does affect the larger scale flow to a point. You may notice this year's a little weird compared to other years with an El Nino. For example, the Atlantic is super warm, and usually it's not quite this warm during an El Nino. Another thing that's a little different about this year is we have a negative signal from the Pacific Decadal Oscillation, and the short version of why we care is that tends to make the sea surface temperatures up here lower than normal, which also affects the atmospheric flow. And you don't usually get real warm water down close to the equator with El Nino. At the same time, you get relatively cold water farther north with a negative PDO. So there's some weirdness there. Another wrench in the works, because why not, is when you have activity out in the western North Pacific, like typhoons, they tend to go north and recurve. There was one that impacted Japan not super long ago. And that can then affect what the jet stream does across the Pacific, and thus what kind of flow we get over here on the west coast of North America, and thus things like that low pressure system that helped catch Hilary. So a lot of things happened to occur kind of at the same time. likely related to some of these climate factors, such as El Nino and the Pacific Decadal Oscillation. But because an individual hurricane is on the shorter time scale than those larger atmospheric or climate phenomena, it's hard to say specifically this was due to El Nino or this was due to the Pacific Decadal Oscillation, especially because this year is a little weirder than what we're used to seeing.
And then sort of part two of that, again, getting toward the focusing on the SSTs and then looking at least with one eye on climate change. Do you see these types of storms like Hilary as becoming more frequent? Are we going to start normalizing, that tropical impacts somewhat regularly in the Southwest because of this? I mean, obviously the one slide that you had where, there's no blue and it's only red over the last 40, 50, 60 years. Is this just a harbinger of more frequent events to come?
So there's things in favor of it being more common, and then there's things working against it being more common. You can kind of see a hint of that in just this loop, which is this massive area of dry air that is dominating much of the eastern North Pacific. Usually something like this would have a better chance of harming a tropical cyclone. But we see in this particular example that Hilary brought a whole lot of moisture with it. And then when you have a system like this low pressure system up here, that can impart what we call divergence, which is upper level flow that helps make air rise below it. And that tends to benefit thunderstorms. So if you have that and the hurricane itself is able to withstand or avoid some of this dry air, then that helps an event like this become a little more likely. Now, with climate change, we've got these competing factors. We've got the increasing warmth of the ocean, and we also, in many places, have an increased drying, just because what goes up must come down. So we might have more intense sinking air in places like out here, and that sinking air tends to be dry, which is not conducive to hurricanes, and sinking air is not conducive to hurricanes since they're powered by thunderstorms and thus rising air. And so we also have those caveats of what is the jet stream going to do? If the jet stream stays more east-west, what we call zonal, then we get fewer of these wavy features that could affect the ability of our normally westward trekking hurricanes to turn northward. So if the ridge that on average tends to be here gets stronger over time, that is a factor that could limit the influence of these systems on the Southwest US. But if we get these competing factors that then induce waviness, like what we saw with this low pressure system, then if a hurricane is present, it could be able to navigate its way northward. The other thing to consider is, just the existence of hurricanes in general. And so we're seeing some competing evidence for, are we going to get more hurricanes or not? The thing that does seem more solid as we learn more is when hurricanes develop, they do seem more likely to get strong and to get strong more quickly, just because there's so much energy available to them from the warm ocean. There's that potential tropical cyclone 9 out in the Gulf of Mexico right now. Gulf of Mexico is incredibly warm. And so if that system organizes, it will likely take advantage, so to speak, of those warm waters and be able to intensify leading up to landfall. So it's, again, that competing thing. Their energy is there from the ocean, but is the atmospheric setup going to also be conducive for hurricanes to form, to intensify, and to get up into the Southwest US? So it's kind of a long answer to that question, but hopefully I covered most of the key points.
Well, we've got some great questions coming in. In fact, our current AMS president and our incoming AMS president have submitted questions. Brad wanted to, sort of ask, connecting your observations in what's going on with Hilary to climate projection models that go out. Are they indicating some sort of increase in these events in the future? And I'll preface all of this by this event is ongoing. You didn't have weeks and weeks to prepare for this webinar, so if there are questions you can't answer or you want to get back to possibly even submitting a post to our weather band members, we can certainly take some time in some of these responses. And then there was Angelique had the question about, have you been able to compare sort of the latest rainfall totals to the winter of 1997-98? Again, a very strong El Nino. Are these comparable? Obviously, two different times during the year, but sort of scale one against the other.
Yeah, so I appreciate, Doug, that you mentioned the limited time I had to prepare for this webinar, because there's a whole lot of data still coming in that I haven't looked at, let alone looked at, past events. But I think it's a good idea to think about how can we place this in the context of past events, either from a also tropical perspective, so this time of year, or from just other years that have produced heavy rainfall regardless of time of year, such as from strong El Nino events. So no, it's not something I've done yet, but it would be a good thing for me to do, hopefully when I have time, or if anyone does do that who's listening in and happens to get to it before I do, please share. I would love to see it. With respect to Brad's question about looking at climate projections, this basin tends to get less focus than other basins, in part because impacts like this are so rare. Some efforts have looked more into how is the North American monsoon potentially going to evolve in the context of changes in the circulation. What's that high pressure system doing up there? But one of the things that I'm getting back into by moving to the University of Arizona is really diving into climatologically, what kinds of patterns have we seen in this region, and how might evolution of those patterns help explain some of the things we're seeing in recent years, and thus give context for what our climate projections say could happen in the future. What's a little weird is I was planning to do this without Hilary, and then Hilary just gave me a whole lot of motivation to really dive back into this line of research.
Wonderful. We have one more question in the chat, and then I have two questions remaining of my 5 or 6. So thank you for taking the time here. Philip asks, how common is the low pressure that was off the coast of Northern California ahead of Hilary is for this time of year? Again, sort of the meat of August here.
Let me get back to this pair of maps. So these are showing the 30-year monthly average for August from 1991 to 2020. And so we see that in general, we get a ridge over the US, but we do get this kind of wavy look to the geopotential heights and the corresponding wind field to the north, kind of near off the coast of California. What's unusual about this setup is it happened in conjunction with a hurricane existing. Now, I'm going to tell a quick story, hopefully quick. When I first got into grad school, I grew up in Oregon, and I went to grad school here at the University of Arizona. And when I was doing work on impacts of TCs in the Southwest US, I found a storm that looked like it might have reached Oregon. And so, of course, I wanted to study that. Well, it was in 1997. It was August 1997. It was August 19th, 1997, that a storm went extratropical off the coast and then tracked up through San Francisco and brought rain, unusual rain for San Francisco for August, all the way into Northern California, Oregon, and a little bit into Washington. And it was affected by another tropical cyclone. So if you want to read about a really interesting hurricane in the Eastern Pacific, look up Guillermo in 1997, which was a Category 5, and it managed to trek mostly westward, but then turned north, like west of Hawaii, and went extratropical out in the middle of nowhere of the Pacific, and ended up lurking off the coast as a low pressure system that helped Ignacio, the storm I mentioned, do what it did and bring rain to Northern California and Oregon. So one of the things to watch for in this kind of scenario is what's going on to like upstream. So that would be to the west. Is there some, low pressure system that happens to be coming through? Is there something that's been influenced by, say, a typhoon or very rarely another East or North Pacific storm that could be changing that mid-latitude flow, that jet stream, to then enable the spin up of a low pressure system off the coast of California? So to summarize, on average, you can kind of get some lower pressure up here, but for it to be configured like that tends to have some unusual things going alongside it.
Great. And I've never clarified the pronunciation of his first name, whether it's Jan or Jan. I have a best friend whose father's name is Jan and a uncle named Jan. But Mr. Knoll has provided some information in the Q&A on various El Nino years or the El Nino state of different tropical cyclones impacting the Southwest. So I encourage people to look at those. Kim, to kind of wrap things up, I want to focus on the communication side of things and the societal impacts. One, for our viewers, if you follow Kim on Twitter, you'll have seen a tweet where there was passion behind and it seems like every tropical cyclone event this happens, the headline is, tropical storm or hurricane X is downgraded or weakening, all the while impacts are skyrocketing and maximizing. And so I don't know if you want to share some of your thoughts on that. And then kind of a little bit related is the extent of impacts, I feel, usually surprise both meteorologists and the public. And you were showing, the moisture that's, almost entering Canada, but certainly the Idaho and Montana there, yes. Could you talk a little bit about how, like maybe some best practices? Do we need to expand the area that we talk about hazards and the impacts? I always remember Irma, where everyone was focused on the Florida Keys and South Florida, and it was the Jacksonville area that just got hammered with storm surge and flooding well away from the center of circulation.
We could probably have an entire webinar or week-long discussion on all the nuances that come into play when we think about how do we communicate impacts. And hazards are the thing that happens, heavy rain, possible flooding, that sort of thing. The impacts are what happens to me. Like if I'm sitting at home, what do I need to do and what will happen to me? So one of the challenges in trying to convey what could happen to somebody is you really want to put in the time and effort to preparing for your risk if it's going to happen, because it's super annoying to go and put out a bunch of sandbags and then you get like a trickle of rain. And then you don't want to do that if you get a similar type of message later on because, they were wrong before. But part of the challenge is it's associated with a hurricane that then was downgraded to a tropical storm. And people have had experiences with hurricanes. They've seen it on the Weather Channel. They've seen storm chasers. They've seen just social media posts about what it was like to go through a hurricane. And a hurricane's not a point. It's a giant system, as we can see from this animation and all these other animations I've been showing, that it impacts extend well away from the center, and the nuances of what's going to happen to a particular point in time and space depends on what is the storm exactly going to do, what kind of terrain is around you, and what kind of infrastructure is around you. And in the desert Southwest, they don't get much rain. And so it doesn't take a lot of rain, especially if it happens all at once, for really bad impacts to occur in the form of flash flooding, mudslides. I've seen pictures of major roads washed out, of debris flow where the water is just full of snapped trees. Like, you know, trying to wrap my head around that is not easy, but that's a impact from these storms. And so there's a portion of it that is just trying to get at all the different pieces: the rain, the results from the rain, the wind, the results from the wind. But also we categorize hurricanes by their maximum 1 minute sustained wind anywhere in the storm, usually close to the center. That category is a really nice way to classify them, but that category, it doesn't have a good relationship with the impacts, because you can have a really strong storm that's like very small, and so the kind of storm surge it would drive is much different than a weaker storm that's very big, because storm surge is affected by the extent of the wind field. We saw that with Katrina. Katrina was weakening before it made landfall, and yet it produced some of the worst surge we've ever seen. This kind of storm, very much weakening right up to landfall, but look at how far ahead the rain-related impacts occur. So I'm not really sure I'm answering your question, but it's a really, really good thing to be considering, in that what is it the audience you're speaking with values about the information that you need to give them, and how do you tailor your message to their values so that they have a sense of agency, that they can do something to prepare, that they do feel like they know something about what is about to happen to them. You know, give them a little bit of sense of, I don't want to say control, but you want to feel like you can do something. And it's very hard to feel like you can do something when you're getting either mixed messaging, or you're thinking really, really hard about it being a hurricane and hurricanes don't happen here, or it's a hurricane, but now it's a tropical storm. Doesn't that mean things are better in the sense that I'm not going to be hurt as much? So it's a lot of communication is about building relationships, finding out what works for the people that you're talking with, and then working with them to find the pieces that connect with them best so that they can then take action from there.
No, that's great. And I even think it's really pumps up the value of the local forecast, of your local news, because if you're just looking at the headlines from a national scale, all eyes are in, Southern California, and the Nevada, California, Arizona area, not up in Eastern Oregon, and other areas. And so if you're just kind of focused on where the greatest impacts are expected, not at your local level where, far removed from sort of the center of the action, can also get, really noticeable impacts. So hopefully everyone's staying safe up in the Pacific Northwest. Kim, thank you. This is your second time as speaker to these breaking news events, and I want to thank our audience. Great questions. Jan, thanks for the content that you provided. We're really trying to ramp up these breaking news events as they are occurring. We've done it twice now for tropical systems. We're going to be looking to expand that to winter systems coming into the fall and winter months. And so thank you, everybody. Thank you, Dr. Kim Wood. Gideon, do you want to close this off?
Well, thank you very much. Thank you very much, Kim. Thank you very much, Doug, for taking the time to do this for us today. It was a very informative, compelling event. So again, many thanks. And audience, thank you too for joining us. Just as a reminder for our audience, all webinars will be available to Weatherband members at amsweatherband.org. And if you have any further questions, or if you want to talk about the webinar, we invite you to join us at the Weatherband Community Forum. With that being said, again, thank you everybody, and we'll see you later.